The St. Louis Gateway Arch began its design process in 1947. On February 12, 1963, the monument began its 2-year construction, ultimately being completed on October 28, 1965.
The St. Louis Gateway Arch is unique in the way the arch is constructed and designed. There are not that many other structures in the world that are shaped the way the arch is. The arch is a weighted catenary curve. This means that the shape is a free-hanging chain that takes when held at both ends. Because of its design, the arch sways as much as 18 inches and can withstand an earthquake. However, under normal conditions, the arch does not sway. It takes up to a 50-mile-per-hour wind to move it. Trams were placed in the arch in 1967 and 68 to take visitors to the top, where small windows are placed to look over Missouri and Illinois.
The major professions that played important roles during the construction of the arch were the architect, designers, engineers, contractors, and steel manufacturers.
From the lead architect, Eero Saarinen, to the lead structural engineer, Hans Carl Bandel, to the subcontractor, the Pittsburgh Des Moines Steel Company, every professional a part of the Gateway Arch construction required expertise on designing and planning for architectural elements that would be both aesthetically pleasing but applicable to the arch's concept and stability. In addition, every professional involved needed to be competent and prepared to handle unexpected changes to the arch and be ready to civilly collaborate to achieve the end result. Finally, professionals on the project needed expertise on the materials planned to be used, the longevity of those materials, the budget, and without a doubt, time and timing, all of which had to be exchanged promptly and smoothly.
Although the arch was simple enough in design, it proved to be quite a challenge to execute. One of the challenges they faced was the conveyor system to get visitors to the top of the arch. They created a conveyor system that would pull individual carts to the top of the arch because a normal elevator system would not work because of the curvature of the arch. They went through several ideas, including an escalator design and a Ferris wheel design, but both would not work efficiently to get visitors to the top. Another challenge was making sure the measurements were absolutely accurate. The builders built both the legs at the same time, so it was crucial that the measurements were incredibly accurate. Any miscalculation would result in the legs being out of line when they met at the top, which could ruin the solidity of the structure as a whole.